Okay, hi everyone. We'll go ahead and get started. Thanks for coming. I know it's probably been a long week, so hopefully you can rest up this weekend. So some announcements to start with. Homework 3 was due yesterday, but if you're using slip days, then you basically have till tomorrow to turn it in. So make sure you get that in if you haven't already. We're starting Python this week, so Maddie started that yesterday in lecture, and then hopefully you saw that in discussion and lab this morning. So the first lab of Python is going to also walk you through how to install Python. So hopefully you saw that today in lab. And if you haven't seen that today, the lab is posted online. So if you need to install Python to get started working on homework 4, you can follow those instructions in that assignment or in the lab assignment over the weekend if you want to install it to get started on the homework. But yeah, that lab will be due on Monday. And then homework 4 is going to be released later today and it'll be due Tuesday. So that is like a bit of a quick turnaround, but it's a much shorter homework, especially like a much shorter homework from homework 3. It's basically like an assignment where you're going to be translating from Snap to Python. So it'll kind of like tell you exactly the code that you're writing. Like you'll see the Snap code and you're just going to directly translate it to Python. So it should be pretty like a little more straightforward than the other homeworks where you're kind of building something from scratch. So yeah, that should be released later today. And then another note is that I know like we had a lot of stuff packed in before the midterm. The like labs and lectures are going to be a little bit lighter, like over the course of the rest of the semester. Like they're a little more spread out. You're not necessarily going to have a lab every week, and you also like in lecture there's going to be some like special topic lectures, so like social implications or like guest lectures. So hopefully it'll be a little calmer after the midterm, and that's because in a week or two, you'll also be starting your final project. So we want to give you guys time to work on that, even in lab as well. So yeah, hopefully it's a little more chill. We just had to squeeze all the Snap stuff in before the midterm. Yeah, and then another note is if you're ever feeling sick or anything, just make sure that you aren't coming to class. Stay at home until you recover, and also email CS10 at Berkeley for instructions to make up attendance points. So never feel like you need to come to class if you're like sick or anything. You can always make that up. Just email us and let us know. And then another note, late add deadline for assignments is this upcoming Tuesday as well. So make sure you get that in if you're someone that applies to. And then last note is midterm scores are released. So I'm going to talk a little more about midterm scores in a second, but is there anything else regarding logistics that people have questions on? No? Okay, let's keep going then. Okay, so I said I was going to talk about midterm scores. So hopefully you saw that. I think they went out this morning. So this is what the histogram looks like. This is what the mean looks like. This is out of 140 points. So this is like about 63%. This might be like low compared to what you've seen, especially I know we have a lot of students coming from high school. But this is like not super out of the ordinary for a CS class at Berkeley. And this doesn't mean that like you failed if you did like maybe you're used to getting like 90s and stuff like on exams. It's not anything like that. This is what the histogram looks like. This is what the average looks like. Even if, yeah.
Is the 87 like 87 out of 100 or 87 out of 140?
It's 87 out of 140.
Okay, so the median and 87/88.
Yes, out of 140. Yeah, I only converted this one, but this one is like about 63%. And as you can see, the standard deviation is also like pretty big. But yeah, so that's what that looks like. You can look on Ed for like the post on that. But again, just some notes about this. So the exam was graded out of 140 points. So your score that you see on Gradescope is out of 140. But your midterm category in your grade is only worth 80 points, right? So that means that whatever your score is out of 140 for the paper exam is going to be scaled down to be out of 60 points. So like basically you can divide it by 140 and then multiply that by 60 to know how many points out of 60 you would have for the paper midterm. And then similarly for the lab midterm, I think the lab midterm is a little easier because on Gradescope itself, it's already graded out of 20 points. So you'll know exactly how many points you have. Also, that histogram was for the paper midterm. So yeah, you can calculate like how many out of those 80 points you would have for your grade. But a couple of notes about this is don't panic if your score isn't like exactly where you wanted it to be. Like I said, first of all, you might not be used to seeing like averages like this. This is pretty normal for like a CS course. And it doesn't mean like, just because we generally have like low averages, that doesn't mean that we generally like fail half the class or something like that. That's just like where the score ends up, and then we adjust as necessary. So the distribution in the end of grades will end up very similar to like all past iterations of the course. So yeah, so don't panic about that. Your score is not like a sole reflection of all the work that you've done this summer. There's a lot of points left like in the course to account for, and you've also already accounted for a lot of points like with your homeworks, with your labs, things like that. So there's a lot of other parts to your grade, not just the exam. We know that the exam is hard. The exams are kind of meant to be the hardest part of the course, but we're super proud of you for doing like as well as you have so far. And again, there's more points to earn to cover this. There's also the clobber policy, which we have hopefully been mentioning. So hopefully you're aware of this, but the final, if you do so it's going to take your raw score. So it's not related to the mean at all. So it doesn't matter like what the average is. That's not going to affect like how this clobber will work, but basically your raw score on the final, if you do better on the final than your midterm, it'll fully replace that score. So that's one way that you can get points back. So technically your entire exam portion of your grade can still be accounted for with that final. And then one more thing is that you can earn up to 10 points back on your exam score by completing the midterm redo assignment. So this is for anyone who wants to, you can, and this is posted on Gradescope already. I think Vedansh put out a post this morning with the exam scores, with the histogram and everything. It was like a really long post, but it also had information about this redo assignment. Basically, for the redo assignment, you're gonna redo 3 questions from the exam, and the exam and the solutions for the exam are already released. So it's not like you kind of like will have a lot to work with, but basically we want you to write up just like a small write-up on like what you put as your answer, what the correct answer is, and like either why your answer was wrong or why the correct answer is correct. So you'll see on Gradescope that is there. You don't have to do the entire exam. It's just 3 questions that we found like the most students missed or we thought were the hardest for students, just so that you can kind of use this midterm as a learning experience. And that's going to be due on next Wednesday. So next Wednesday. So that's the 20th. And that's already out on Gradescope, and the solutions for the exam along with the exam PDF itself are posted on Ed with the same post that like went out with midterm grades being released. So all of that is pinned on Ed. If you're having trouble finding that, let us know and we can make it more visible. Yeah, maybe we'll make a separate post with the midterm redo assignment just so that it's there separately. But yeah, so you can get up to 10 points back on your exam score for that. So that means like out of the 140, it's going to add 10 points to that to the paper portion of your score, because you're going to be redoing like the paper portion. And then that'll again be scaled back to be out of 60 points. Does anyone have questions on the midterm redo? Does that make sense? Okay, cool. Yeah, let us know if you have questions about that. And then one more thing is we wanted to offer some appointment-based instructor office hours to discuss like how the exam went for you, as well as maybe some study strategies for next time if you are looking for that. So we're going to post signups on Ed for that probably tomorrow. So those will be held by Maddie and I online, and those will be about 10-minute slots per person. You can just sign up, and basically it's kind of like up to you what you want to go over. So whether that you want to go over your exam and go over what you got wrong and understand kind of why you got that wrong, or if you just want to talk about how you're doing in the class, it's kind of the same as normal instructor office hours, but usually after an exam, a lot of students want to like kind of talk about their grade and stuff. So we wanted to offer that on an appointment-based system, so you're not waiting in like the office hour queue for a long time. So a signups for that will be out tomorrow, and then we'll probably hold them like either like over the weekend, so either Saturday or Sunday in the morning on Zoom, or like early next week, depending on what people's availability is. So yeah, look out for posts on that. Are there any questions about anything related to the midterm? Okay, cool. In that case, we can keep going. So again, we're moving on to Snap. So we're moving on from Snap, we're moving on to Python. So if Snap was kind of tricky for you, it's kind of like a fresh start. We're going to Python. So yeah, we can get started with this. So first, we're going to talk a little bit about object-oriented programming, finishing up what Maddie's slides were on yesterday. So Maddie talked about a couple concepts that don't necessarily translate that well between Snap and Python. And by translate well, we just mean that like there's some things in Snap and Python that are very clear. Like if you're setting some variable to some value, in Snap you just do set and then the variable name and then the value. And in Python, you just do the variable name equals the value. So it's kind of a direct translation versus some of these concepts like slice notation, explicit variable types, and object-oriented programming are pretty different between the two. So we're going to talk a little bit about object-oriented programming right now. So object-oriented programming, if you recall from the programming paradigms lecture, which was the last one before the midterm, The definition of it is in object programming, we organize our thinking around objects, each containing its own data and each with its own procedures that can be invoked. You probably haven't like used this term that much in this course, but actually Snap is very well designed to account for object-oriented programming, because in Snap we have these like different sprites, and I just kind of changed the costumes here, but these sprites all exist in Snap, and you can think of each individual sprite as an object, and these sprites can interact with each other. And you'll see this when you're doing your final project. If you're building a game or something, it can be really useful to have these sprites interacting with each other, and those are what are representing objects. So that's how we do object-oriented programming in Snap. Whereas in Python, it's a little different, because in Python, every single variable that we have has a type. And in Snap, they also have a type, but it doesn't have to be necessarily predefined in the way that it does for Python. And each type in Python also has its own set of functions that it can perform. So, and functions in Python kind of map to blocks in Snap, right? And in Snap, when we create a block, you might have noticed that sometimes it gives you an option if you want to create the block only for this sprite, or if you want to create it like for all sprites, right? So that's kind of the same idea here. So in Python, all functions are defined usually for a specific type, or they're often defined for a specific type. And so each type has its own set of functions that can perform. So maybe like the add function in for like a list does something different for a different type of object called a dictionary, which we'll talk about in a second. But basically the important thing to understand here is that every variable has a type, and we can refer to those variables as objects, which have their own set of functions depending on the type. And we'll talk a lot more in detail about object-oriented programming on Tuesday's lecture, because there's a lot of cool stuff you can do with that in Python, but this is just an intro to understand when we start talking about some different data structures in Python and the functions that can happen with like lists and strings. Are there any questions about this slide? Is this making sense? Okay, cool. Let's keep going. Okay. Yeah, so we're going to talk about something called dot notation, and this is really why I'm including this in this lecture. So the syntax for, when you call a function on a specific object, you're going to use this thing called dot notation, and it basically looks like this. You have your variable or your object that you're calling a function on, and you do dot, and then you do the function name, and then you pass in whatever needs to be passed in. So in this example, we're calling the function append on the item list, or sorry, on the variable list, which is an object, and we're calling it with input a string that says ketchup, right? So this is what dot notation is. It literally just means that you're putting a dot between things. But basically this code right here is actually doing the same exact thing as the snap code. So the snap code, if you look at this, we're creating a variable called sum list. We're setting that variable to be this list of 2, 4, 7, and 11, and then we're adding ketchup to the end of sum list, right? So this is the Python code that's doing that same exact thing. So in one line, it creates the variable and it sets it equal to this list, and then it appends ketchup using this dot append function. So the difference here is that in Snap, when we call this function, we're calling a function with an input, and then adding the second input, or adding this first input here to the second input. Versus here, we have this object and we're calling the function on the object itself. So the object is kind of doing the work of adding the item. So this is like a little visual for what this looks like. So this is our like Snap version. So this is kind of like our function, this machine, and it takes in two values. It takes in our list and the item that we want to add, and it does the computation of adding them and outputs that. Versus here, the function is owned by the object itself. So this object in this case was a list, and the list object owns this dot append function, which will allow you to add items to the end of the list. So it just takes in one input and adds it to itself. So the list itself does the work of adding instead of an outside function doing that. Yes.
So in the end, the list would be 2, 4, 7, 11 ketchup?
Yes, exactly. Yeah, exactly. And it's going to just add it to the end of that. Yeah, so that's basically the idea, and we'll see some more examples of this. You'll see a lot of examples of these functions in lab, but just to give a little intro of like why we're doing this dot notation thing. So when you see the dot something, that means that you're calling the function on a particular object. Does that make sense? Are there any questions about this? Okay, let's keep going. Okay, and then, yeah, so each type has its own special set of functions. And there's like a really, really long list of these on the documentation website. There's no need to like memorize these functions or anything. You can always refer to these while you're doing labs and stuff. We'll only expect you to be familiar with like the functions that you've used very often in lab, and we won't ever expect that you know like a function without looking at the documentation unless we've really used it a lot. And also, all these functions are kind of like helper functions, like they're not actually necessary. You could do this manually using like the built-in things in Python without using these built-in object methods. And we'll talk about that in a second as well. But this is the documentation if you want to use these because they're super, super helpful to like just refer to instead of having to do everything manually. But I think it'll make more sense when we talk about more examples. But yeah, so for this one, so we're also going to go a little more in depth of what a string is, but basically you can think of string as just a piece of text. So it's going to be in quotes. So here, if you remember yesterday, Maddie talked about like this input method. Do people remember that? Does anyone remember what it does? Yes. Yeah, exactly. It takes in user input. So it's kind of like the ask block in Snap. So when you say input and then you put a string here, it basically prompts the user to give some input. So just not looking too deep into this code, we're creating this variable number text, and it's going to save whatever the response was from the user when we said give me, like this. And so here we see this is what's running in our terminal. We see that the user gave 1 2 3 as input to this prompt that it got. And so numbers text is going to be equal to 1 2 3. Then we see that we say numbers list equals numbers text dot split, and in quotes we have a space. Okay, this kind of looks like it's empty quotes, but there's actually a space here. And so what that does, we can kind of see if we look here, we can kind of assume like, okay, it's probably splitting the list in some way. And we see that this is called numbers list. So that's kind of a hint like, okay, it's probably making it into a list. And then when we print numbers list, we see that it prints with these square brackets. That tells us that it's a list. So this is just one example of like a built-in function. And what it does is it splits whatever string it's called on. And it's kind of unclear to see here, but it's actually splitting it based on whatever you give it here. So we see here that we have 1 space 2 space 3. And so it's going to split the list at the spaces. If there were no spaces between this, then everything would just be the first item in the list because it's splitting it on the spaces. Does that make sense? Okay, cool. Let's keep going. So yeah, there's lots of string functions that exist in Python that don't exist in Snap. So you can kind of read the documentation to like see that if you ever need to mess with strings for your final project or for the labs that you're working on. Although usually for labs, we'll like tell you which functions are useful. But you can see here, there's like a dot upper, which converts everything to uppercase, as you can see here. There's a dot count, which is kind of cool. It counts how many characters that you pass in here, how many of them appear in the string. So we see that this gave us 5 because there's 5 A's in abracadabra. And then this one is also kind of cool. So you can do dot replace and give it 2 inputs, and it'll replace every instance of this first input with the second input. So it'll replace every OO with EL. So we see that cool boot becomes cell belt. So yeah, those are just some more functions. Again, you don't have to memorize all these, but just to kind of give you a look at what kinds of things you can do in Python. Yeah, so again, some more string functions. This one is actually really important. So this is dot join. And this is kind of weird, but this is kind of analogous to using combine in Snap when you're using join with it. So if we do dot join, we pass in like an empty string or something here that will join these values. And I think the lab has a better example of this, so I'm not going to go like too much in depth, but basically you can pass in a list and have it join if you want to join it with commas in between, then you would do comma and you can put a space if you want a space in between them, and call dot join on that string. If you call it on an empty string, it'll just join everything together without any spaces or anything. So basically whatever you want in between the items of your list is what you would put over here. Does that kind of make sense? Okay, I think this is something that's probably more useful when you see it in practice. So I think lab will be helpful for that. But yeah, so moving on to list basics. So we kind of talked about this yesterday, but lists are super, super important in Python and in Snap, as you've probably already seen. So we're gonna review kind of how we make lists. Do you guys remember how to make lists? Is this familiar? Okay, did you guys work on Python today, or were people mostly working on yesterday's lab? Anyone? Yeah.
I think a lot of people are having trouble just like running Python.
Okay, like installing it and getting it going.
I mean, just like figuring out how you can use
The text editor and
then
terminal.
they need to run it, a lot of things weren't working.
Okay, I see. Thank you. Yeah, okay. So let's go a little bit more in depth with lists then, and then hopefully by Monday, by the next lab, like people will kind of get those details figured out. I know it's really confusing to like start using like Python, because when you start in Snap, everything is right there. But then when you go to Python, you have to deal with like the terminal to run your code, and then the text editor to write your code. So it's kind of weird to go between those. But that'll come with practice. Okay, so in that case, let's go over lists. So we make a list in Python by putting items that we want in our list in square brackets and then separating them with commas. So it looks something like this, and we want to save those into a variable. We put the variable on the left-hand side of the equal sign and whatever we're assigning it to on the right-hand side. So this is basically just creating a list that has 0, 10, 20, 30, 40, 50, and saving it into a variable called SUMList. So yeah, that's just this line of code. And then we can always get the length of a list by calling the len function. So len, and then if you open parentheses and put a list inside of it, it'll tell you the length of that list. So it's kind of like that length block in Snap, but in Python, it's just called len. So what is this going to output if we say len of some list? And this is our sum list. Yeah. It would be almost 5, but remember this, even though we're 0 indexing, the length is still 6. So there's still 6 items. But yeah, this is kind of confusing with 0 indexing, and we'll get to that in a second. But yeah, this is going to output 6. It's just going to be the length. But you do have to be careful because the last index is not necessarily the length of the list. It's actually usually one shorter than the length of the list. Yeah. So, and then we can also access values in our list by indexing into the list using square brackets. So this is the square bracket notation. So we use usually everything to do with lists is usually revolving around square brackets. So we use square brackets to make our list. We can also use square brackets to index into our list. So this is like in Snap when you use the item of block. So if we have some list and then we have square brackets 0, what is this going to output? 0, right? And then if we do some list of 4, what is that going to output? Yes, I think. Wait, 0, 1, 2, 3, 4. Okay, so we start with 0. So this is going to be 0, and then 1, 2, 3, 4. So it's going to be 40. Does that make sense? So this is something that's like different from Snap, right? Because in Snap we have, did Maddie talk about 0 indexing yesterday? She did, right? Yeah. Okay, just in case people are confused what I'm saying about 0 indexing, that means that the first index in our list is index 0. So in Snap, the first index in your list is index 1. Like the first item in your list is item 1. But in Python, the first index in your list is item 0. And that's just a thing that exists in most programming languages. Basically, all programming languages aside from Snap use 0 indexing. So the first item is always item 0 or index 0. And that's something that can get really confusing if you forget. So make sure that you keep that in mind when you're like trying to debug your code. But yeah, so does it make sense why item 4 is 40? So it'll be like item 0, item 1, item 2, item 3, and item 4. Does that make sense? Okay, awesome. Okay, and then, so this one's a little trickier. So we're saying some list, and then the index that we're doing here is len sum list minus 1. So we already said len of sum list is what? 6, right? And so if we do minus 1, that'll become 5. So what is this going to output? Then this is basically saying sum list at index 5. What is that going to be? 50. Yeah, exactly. So this is going to be 50. So we took the length of the list and we subtracted 1 from that. And that's actually always going to give you the last index in your list because of 0 indexing. So the length of your list is always going to be 1 more than whatever that last index is. So if you subtract 1 off of that, that's like a quick way to get the last item in your list if you don't know how long your list is. And because that's always the case, Python kind of has this shortcut where you can use this thing called negative indexing, which means you can say like -1, and that'll by default give you like the last item in the list. So if you say, so this is also going to output 50 then. Then if you say -2, it's going to go to the end of the list and it'll go like 1, 2. So it'll output 40 if you had -2 here. Does that make sense? So basically negative indexing is starting from the back and like going backwards. That's not like super common, but sometimes it's useful. Like if you don't know how long your string is or how long your list is, sometimes you might want to use negative indexing to count backwards from the end. And I think you might use that in some of your labs as well. So it's good to know. Does that make sense how we index into lists? Okay, awesome. Okay, let's keep going then. So yeah, so we can also do this thing called slicing, which I think Maddie did talk about yesterday. So we can slice our list to grab subsets of items in our list using square brackets with a colon in between the start and end indices. So what this means is we have this list 0, 10, 20, 30, 40, 50. We want a slice of it. Basically, we just like want some small portion of it. And the way that we do that is we use square brackets again. And if we want to get like a portion of our list, kind of like a range of within it, we need the starting point for that range and the ending point for that range, right? So the syntax for that in Python, and syntax is just like a fancy word for like the rules for writing the language. But the way that we write that is we put a colon in between the two numbers inside of our square brackets. So this is going to give us values from index 1 of our list to index 5. And another thing to remember, and I think Maddie mentioned this yesterday, is the left side is going to be inclusive and the right side is exclusive. So that's something to get used to, because in Snap, everything was inclusive. If you had like a for loop from like 1 to 5, it did like 1, 2, 3, 4, 5. In this scenario, this is only going to get indexes 1, 2, 3, and 4. And I think this example is from yesterday, but does anyone know what this would output then based on what I've just said? Yeah. 10, 20, 30, 40. Yes, exactly. It's going to give us a list of, did it work? Okay, yeah, it's going to give us a list of 10, 20, 30, and 40. And so the reason for that is, again, because we're going to go from index 1 up until index 5. So we'll do 10, 20, 30, 40, because this is index 0. So this is index 1. And this one was index 5, as we've noted previously. Does that make sense? Okay, and then another cool thing is that if you leave the endpoints off, so basically like on one of the sides of the colon, if you leave it off, by default, it's going to go to the end of the list, depending on whichever side you left it off. So if you left off this index, by default, it's going to go all the way from the beginning of the list because you didn't give it a number to start at. So it's just going to assume that you're starting from the beginning. So this is going to go from index 0, basically from the beginning until index 3, but it's not going to include index 3. So what would this output? Thoughts? Is it clear what I said about that it's going to start from the beginning if we leave it off? Yeah.
0, 10, 20.
Yes, exactly. It's going to be 0, 10, and 20. So we're going to go index 0, index 1, index 2, and not index 3. And then similarly over here, we're going to start at index 2 and we're going to go till the end of the list because we left it off. And we're going to go all the way to the end. So it's going to include index 5 as well. So it'll be 20, 30, 40, 50. Does that make sense? Okay. And then lastly, if we just leave off both, does anyone have ideas of what that would do based on what I've just said? Yeah. Yes, exactly. It's just going to reprint the whole thing because like I said, if you leave off the left-hand side, it's going to start from the beginning. If you leave off the right-hand side, it's going to go all the way to the end. So if you leave off both of them, it's just going to give you the whole list back. Does that make sense? Okay, slicing is like really important. So you'll probably see it a lot in your labs and stuff. But yeah, and then one last thing for this slide is that you can also change the value of an item in a list by accessing that item using indexing and then reassigning it to the new value. So what that means is, remember, if we do sum list of 3, ignore this equals 35, what would sum list of 3 give us? It would give us like the third index in our list, right? Or index 3 of our list. So 0, 1, 2, 3. This is index 3. So we'll grab that value. And since we're saying equals 35, that means we're setting it equal to 35. So remember, an equal sign in Python, it's called like an assignment operator. It assigns values. And Maddie talked about this yesterday, but if you have 2 equal signs, that's going to give you a Boolean. That's going to check if values are equal. But we're not using that here. We're just actually assigning the index 3 of some list to be 35. So now what is our list going to look like if we reprint this after making this change? Anyone know? Yes.
Is it 0, 10, 20, 35, 40?
Yes, exactly. Thank you. Yeah, so it's just going to replace item 30 with 35. So notice that 30 didn't just like get shifted over or anything. It got completely removed when we replaced it with 35. Does that make sense? Okay, so this is kind of like the replace block in Snap. Any questions about these? Okay, cool. Let's keep going. Okay, so there's a lot of other built-in functions in Python which can be used to change a list. So these mostly all are going to use dot notation. So that's what I was talking about earlier. So for example, dot pop, dot append, dot remove. Again, here's the same documentation that has all the different functions that you can use. We don't expect you to memorize these, but you should just be familiar with the ones that you use often in lab or in other assignments. Most of these functions, and this is really important, most of these functions are going to actually mutate or change the list itself rather than returning a new list. So if we go back on this slide, right, when we grab like 2 colon, then we're getting index 2 till the end of the list. This is actually returning like kind of like a copy of that list. It's returning a new list between these indexes that we gave it. And when you do like dot pop or dot append or dot remove, this is actually going to change the list itself. And actually on Monday's lecture, we're going to talk a little bit more about, or actually we're going to go a lot more in depth about what it means to change the list. But essentially what it means is that if you do some list and then you remove 3, this is going to remove index 3 from our list. Then if you refer to some list again, it's no longer going to have whatever was at index 3. It's going to have something else. And you'll see that in lab, you'll see that in lecture on Monday as well. But yeah, so these dot functions usually actually mutate the list. But you should always, if you're using like a new function that you're using on a list and you've never used it before, you should always read the documentation to make sure whether or not it mutates that list. And like even to this day, like when I'm writing code in Python, if I'm like using one of these functions, I always just like Google it really fast and see like, does dot pop mutate the list? Does dot pop change the list, or does it return a new list? Because that can lead to a lot of bugs if you're not aware of that. Like you probably saw in homework 3 if you finished it or if you've been working on it, that we always have you make changes on a copy of the board so that it doesn't mess with the original board. So you always want to be aware of if the function that you're using is making changes on a copy or if it's making changes on that list itself. Does that make sense? Okay. Awesome. Okay, let's keep going. So we're going to talk about something called list comprehensions. But really quickly first, I just wanted to put this slide up from yesterday's lecture. So this is how you define functions in Python. And again, functions are kind of like analogous to blocks in Snap. So if we're defining like it is even block in Snap, it would look something like this. If we want to define it in Python, we're going to have def and then the name of the function that we're defining and then whatever inputs there are, and then a colon, and then the definition is going to be indented inside. Does this make sense? Okay. So as we've done often with functions, sometimes you want to map that function over a list, right? And I'm sure you saw this a lot. I know it was like kind of confusing, the question on the midterm as well using map. But in Python, we also have this map function. So again, if you need a reminder, map, what it does is it takes some function and it applies that function to every single item in a list, right? So say we have this function here, def reverse. It's not important to understand like the code here, but just assume that this function takes in a string and it reverses that string. So if we take in the string like m or like am, it's going to reverse it and it's going to make it ma. And we want to map this reverse function over every single item in our list L. This is how you would do that. And again, the equivalent of the Snap program looks like this. So it's reversing these items one by one. Does this make sense? Okay, yeah. So this map function exists, but there's like something that's a little annoying about this map function is that it returns this like object called like a map object, and it's not actually returning a list. So if we want our answer to be of type list, our reverse list, we have to call this function called list on it to convert it into a list type. So I think Maddie talked about this a little bit yesterday, but basically, if you're calling map, it's not going to return a list unless you do this. It's really easy to convert it to a list. You just write list in front of it and put it in parentheses. But it's important to remember to do that because since it's a map object, it's again not going to have access to those functions that exist only for lists unless you include this. So yeah, so that's one thing. However, you're actually probably not going to use map a lot because there's something that's much simpler to use and much more intuitive called a list comprehension. So map works to do exactly what we want it to do, and it works perfectly well. But using a list comprehension is a lot cleaner in your code, and it also is kind of like, it makes it more readable. So all three of these programs below are equivalent. So this is our map function that we just talked about, converting it into a list. This is how you would do it in Snap. This right here is how you would do it in a list comprehension. So this is a little weird to like look at and understand at first, but once you do some practice, I think it'll make a lot more sense. But basically, what happens is over here, you put the function name and what you want to call it on, and then you say for X in whatever you're iterating over. So if you want to apply something to every single item in L, then you say for X in L, and then you say what you want to do to that. So this is going to output this for every value in L. And X is kind of just like a placeholder. It's just a variable name. So you can actually call this whatever you want. You can call it like element, you can call it number. But the important thing is whatever you call it here is what you have to call it right here so that it knows what to call it on. Does that make sense? So it's kind of like this variable is getting assigned one by one to the values in L, and then this function is going to be called on it, and this is going to output a new list. And then the other thing that's important is you have to include these square brackets, because if you don't include the square brackets, then it's just going to error, because a list comprehension is like a very special syntax that exists. And if you have this like for in stuff, it's going to get confused if it doesn't have the square brackets. And this kind of indicates that this is outputting a new list. But yeah, so basically this would do the exact same thing as map, but it's kind of cleaner, and we can also do it with a filter, which I'll show you in a second. But does this make sense? Are there any questions about the list comprehension so far? Okay. Okay, yeah, so the syntax for list comprehensions, as we've seen so far, has three components. It has the square brackets surrounding the list comprehension. It has this for thing, so for some variable in some list. And again, these are just temporary variables, and these are just placeholders. So it can be whatever you decide to call it. But whatever you put here is going to be representing each item in whatever is here. And we can apply any arbitrary function over here to our values one by one. Does that make sense? Okay. And then, yeah, so Python also has a version of keep. So keep from Snap allowed us to select certain items in our list that matched a condition, right? Do we remember that? Yeah. Okay. So in Python, we have a version of that called filter, which can be combined with map. But as you're going to see in a second, we're mostly going to do with list comprehensions instead. But that'll look something like this. So say we have this function longer than 2. It tells us if our string is longer than 2. So if we want to first filter our list to have only words that are longer than 2, and then we want to reverse it, we would do it like this. So this is like equivalent to doing this in Snap. Does that make sense? Any questions about this filter function? Okay, but again, you're probably not going to use this because you can just do all of this in one line with this list comprehension by just adding on an if statement to the end of your list comprehension. So before, on the previous slide, we just ended our list comprehension right here with our square brackets to reverse the list. If we want to only reverse the list after a certain condition is applied, then we can just add that on as a special if statement right here. So we can say reverse X for X in L if len of X is greater than 2, right? So X, again, is referring to each item in our list called L. And it's saying if the item is greater than 2, then we want to reverse it. And again, we're going to output a new list here. And these square brackets, again, are super important because otherwise it's not going to know to output a list. Yeah, and this note here is saying that the syntax in the list comprehension is very special. The if is not a normal conditional. So this is like the exact formula that you want to follow when writing list comprehensions. It doesn't read as like normal Python code does. Because usually with an if statement, you would have to have like a colon and stuff underneath. But since this is in a list comprehension, it's a special syntax for doing this. Does that make sense? Okay. So this is a summary slide. I would like take a picture, save this, write this down. I mean, the slides are posted, so you can refer to it. But basically, this is the way that list comprehensions work. So if you were trying to do map and snap, this is how you do it with your list comprehension. You would say f, and f is your function that you're trying to map over the element. For element in iterable. Iterable is like some object that you can iterate over. So that's usually a list, but you can also do it with strings. And we're just applying that function to each element. So it's going to look something like this. Again, element is a placeholder, so it can be whatever you want. I often just use X just for simplicity, but it can be anything that you want. If you want to do keep, and if you don't want to map, you just want to do keep, then you're going to say element for element in iterable if the condition, and this is whatever function you would pass into keep if that condition is true. So basically, this is where you're putting your condition. The reason that we do element for element, then we don't want to change the values. Like remember, keep didn't ever change the values of our input list. It just gave us like a filtered version of it, right? Unless we used map. Map actually changed the values, but keep kept the values the same. So that's why we do element for element here, because it's just keeping the element the same, unless we're going to call a function on it, in which case you could do this combined version, which applies the function as well as keep checks the condition and decides what to keep. Does that make sense? Okay, this last case is like, it also works. You can take a look at it, but it's probably not going to be used as often in this class. Any questions about list comprehensions? Okay. Okay, this is fine. Okay, we're going to move on to some more sequences. So we're going to talk about strings really quick. So strings are similar in Python, or similar to text in Snap. Basically, you just put some quotes around it, either single quotes or double quotes. We won't really use triple quotes. But if you use single quotes or double quotes, you can make a string and you can just put some text in it. And you can access the characters in this string using bracket notation, just like you do with lists. And you can also slice them. However, strings are immutable. That means that you can't change the value of something in a string the way that we could in Python with lists. So here we have S2 from index 1 to index 4. So this indexing is the exact same with like the inclusive exclusive thing and the zero indexing. So this S2 is going to refer to this hello Alice string right here. Does anyone have any ideas of what this would print if we were to run this? No? Okay. Well, if we look up here at S2, we have 1 to 4. So that tells us we're starting at index 1 and going until index 4. So if we go here, we see this is index 0, this is index 1, this is index 2, 3, and 4, and we're stopping at 4. So this was 1, so this is going to output ELL. Does that make sense? Yeah? Okay. Cool. And then, yeah, so strings are not mutable. So if you try to do something like this, it's going to error because you can't change the value of something inside of a string. If you want to change S2, the first thing to be a Y, you would actually just have to rewrite S2 equals like yellow Alice instead of hello Alice if you wanted to change that. Does that make sense? Okay. Cool. Let's keep going. Yeah, so lists versus strings, both of these are sequences. They both support slice notation. You can do like this in thing where you check if dog is in this. So yeah, all of these things, they kind of are part of the same family in a sense. So a lot of functions that you can, or not functions, but a lot of functionality that exists with lists, you can also apply to strings. But yeah, and then range really quick. Have you guys seen range in lab yet or no? See one nod. Okay, so basically range is kind of like a list, but it's kind of like a short-term list, and it just gives you a specific set of numbers that are consecutive and depending on the inputs you give. So if you give 0 to 4, it's going to give you the values 0, 1, 2, 3, and it's not going to give you 4. It's not exactly a list, but it's kind of like a type of list, and you're going to use it a lot with for loops. So if we say for x in range 0, 0, 4, X is this is like a for loop. It's going to take on the value 0 first, and then it's going to take on the value 1, and then 2, and then 3, but not 4 because it's exclusive on the right side. And this is basically adding up numbers from 0 to 3. So it's going to add 0, and then it's going to add 1, 2, 3, and then it's going to stop, and it's going to print the total as 6. Does that make sense? What this code is doing? Okay. Yeah, and again, ranges are immutable. So if you want to like change values, you're going to have to use a list. I'm going to skip through this really quick. Yeah, so this basically you can convert values. I think Maddie talked about this. We can't you do like functions that only exist with lists if we're dealing with strings or if we're dealing with ranges. So you need to convert it. Like in this case, we need to convert our text to an integer in order to print it. Or sorry, not in order to print it, but in order to add it to a string because they have to be the same type. Or sorry, to add it to a number because you can't really add strings necessarily the same way that you add numbers together. And the way that you can convert a range to a list is by calling this list function on the range. So if we create a range called x from 0 to 4, and then we add 4 to the end of it, the way that we convert it into a list is by calling list on that function. And this is kind of similar to what I just showed where map was outputting like a map object, right? And so in order to convert it to a list, we had to call this list function on it. So similarly, if we want to convert our range to a list, we can call this list function on it. Now we can do dot append, whereas up here we couldn't do dot append because we were dealing with the range. Does that make sense? Okay. Yeah, someone was asking about this yesterday, I think. So these are tuples or tuples. People pronounce it differently, but basically tuples are very similar to lists, except they're immutable, so you can't change them. And you create them with parentheses instead of with square brackets. And you can, again, access values as specific indexes with square brackets, just like with lists, but you can't change the values. And so a question here is like, why do we even have tuples if like tuples are the same as lists, but they can do less? And the answer for that is because programming languages like they all have their own like quirks and things that make them better to use for certain situations. And sometimes it can be useful to have a data type that can have less functionality than something else because it makes things simpler. Remember when we were starting off, we were talking about abstraction. We wanted to keep things simple. So if we know that our tuples aren't ever going to change, that kind of simplifies our process because maybe we know we only need to check that once. But if we know that we're writing code that needs to change the values, then we might want to use a list. So that's the general thought process behind that. I think I'm going to stop here and I'll finish this up next time because I think dictionaries are like a big topic and I don't want to jump into it right now. But does anyone have questions about like what I showed so far in these sequences? Yes. Yes.
The slides are private.
Oh, okay. Let me just fix it right now. But yeah, are there any questions about this? Are we good? Okay, cool. I will fix that. And did anyone try the self-check? Did it work? Yeah? Okay, awesome. Okay, let me fix this. And yeah, you're free to go. Thank you guys for coming. Thanks for getting through this week. We'll see you next week. Give me 1 second. Let me end the Zoom call.